Everyone, today in this video we are going to be looking at the surface area, how we get the formula for that for a rectangular prism. For that I'm going to use this Diet Dr. Pepper, which I love so much that I've already kind of gotten into it. Anyways, it is going to be my example, so let's go ahead and figure out the surface area of this rectangular prism. That means, what is the area on all the surfaces? That means every single side. Top, bottom, front, back, side. Yeah. Okay, cool. So, let's start with the very front. That's going to be this side here. How do we find the area of this whole rectangle here? This should be review from last week. It is going to be width times length. Now, some of you might go, well, I thought it was base times height. Sure, tomato, doesn't matter. You're going to take this dimension, and you're going to take the other dimension that's crisscross to it. In math, we call it perpendicular, or at a 90-degree angle. And we're going to multiply them together. So, surface area is going to be width times length. Width times length. Okay, so we got one side down, but remember, for surface area, we want every single surface, so every single side. How many surfaces do you think are on this whole container? Did you say 6? If so, let's check. 1, 2, 3, 4, and then there's the top, and then there's the bottom, right? So we have 6 that we need to calculate. Do you think you can figure out what the back side would be if this is the front? It's exactly the same, right? It might look a little different as far as the packaging goes, but the dimensions and the area on this side on the back are going to be the same as what's on the front here. So we can actually take the width times length, and we are going to multiply that by 2. Why? Well, because we know that this side is the same as the back side. So if we find the area for the front, we can just double that to account for both the front and the back. Cool. So we got 2 sides out of 6 done. Let's take a look at, let's do this side first. So we got the height here. Now you might go, that's not the height. Height is talking about vertical. Sure, I mean, I could also orient it like this, and then it would be the height, right? It doesn't really matter in this instance, because really, with a rectangular prism, you can have it any way you want. It'll always be a rectangle as the base on the bottom or wherever you put it. I just have it oriented this way, so if that's confusing you with height, just think of it as a way of labeling a different dimension. Okay, so we are going to add our next area. Let's do this one, like I said. So that's going to be this one here. Now take a look at this drawing here. If we know that this is the width, based on what I wrote here, then this must also be the width, which is this side right here. So this is the width here, and this is the height. Then this whole area on the side, the right side of this whole prism, is going to be, width times height. Width times height. Okay. What's that, you say? The right side is going to be the exact same as the left side? No way. Looks like we got kind of like a smaller rectangle on the side, right? If I look at the other side, it looks like the same exact area because, in fact, it is. So, we are going to, again, say, well, if we know what the right side area is, width times height, that's going to be the exact same as the left side, right side, 2 identical sides. Cool. That means we only have 2 more sides to figure out. Let's do the top side. You can see I already got into it, right? Okay, so how do you find the area of this top rectangle? Well, let's look at the dimensions. That's this rectangle on the top here. That's the only one we haven't done. Well, we know that this one has to be the length. Why? Well, because this was the length, and it's opposite that one. I would say those have to be the same dimension we're talking about. Then we got to figure out, okay, what's this dimension? I actually think it's easier to look over here on the right because that side is going to be identical to what? The height, right? This has to be the height, this has to be the height. That's how rectangles work. So let's put that up there. So, if this is the height and this is the length, it's going to be the same calculation of the bottom side times the side, I guess you could call it. So that's length times height for that top rectangle. Height times length, and then we're going to multiply that by 2. Why? Because the top side is going to be the same as the bottom. That's all 6 sides, right? 2 sides, 2 sides, 2 sides. Notice that you multiply the dimensions for the sides, but then you add them up after you've done that, okay? Don't just multiply everything together. We're not doing volume. Notice a pattern here. We have every single combination of the dimensions multiplied together, right? Width times length, width times height, height times length, okay? I also posted a video that does an example where I actually measure the surface area of this whole thing, so take a look at that if you want a walkthrough on how to calculate that using real numbers. Alright, you guys, go out there, do some math, watch my other videos. See ya.